Students, hope you are all doing well and your studies are also going nice. So today I am here with my another episode on NEET and JEE special in my channel Physics Scholar. So I am your Arka sir. So if you have not subscribed my channel yet, so subscribe it as early as possible and also share it with your friends so that you can get benefit from this. Okay, so now I already uploaded one video on the NEET and JEE special episode on physics. Some numeric problems as well as some theory we have done. So here now let us move ahead. So let us now do these sums. Clear? So what is the sum? A cylindrical rod is reformed to half of its original length, keeping the volume constant. Okay, so a cylindrical rod, okay, a rod is in cylindrical rod, clear? A cylindrical rod is reformed to half of its length, clear? Half of its length means the half of its length, keeping the volume constant. If the resistance before its change was capital R, then the resistance after reformation will be. Okay, so what will be the resistance after reformation? The resistance before reformation is R, and what will be the resistance? Okay, suppose that what will be the resistance after reformation? Clear? Suppose it is R1 is equal to R. So what will be the resistance after R? After reformation, okay, R2. What will we have to? So four options are given. We have to find out that four options are given. R means the initial resistance. That way it will not change. It will be same. R by 4. It will be 4 times than before. It will be what? It will be R by 8. Clear? It will be R by 8. R by 8 and R by 2. Okay. So 8 times than before or R by 2 means half than before. Okay. So now we have to do this sum. Now how will do this sum? The resistance of the rod before transformation. Clear? What we know? If the resistivity is rho. Clear? And suppose the initial length is L1, okay, or the length is L1. So what we know that R1 is equal to R into R is given. Okay, R1 is equal to R is equal to what? Rho into what? What is the formula? R is equal to rho into L by A. So that formula I am writing here. R is equal to rho. Rho means what? Resistivity. L1 means the length of the this conductor. Divided by what? Pi R1 square. Why pi R1 square? Because what? R is equal to rho into L by A. Okay, A means what? Cross sectional area. So cross sectional area will be what? Pi into R square. So pi into R1 square. That will be the cross sectional area of the rod. Clear? Cylindrical rod. Clear? Cylindrical rod cross sectional area. So cylindrical rod is of this type. So cross sectional area it is what? Circle. So raise the radius is R. So it will be what? Cross sectional area will be pi R square. Clear? So if R1 is the resistance, then that will be pi R1 square. Clear? So as the rod is reformed, so the length of the rod is what? The length of the rod is now half than before. Clear? So as the rod is reformed, so what? That is the final length L2. L2 will be L1 by 2. That will be half than before. Clear? Now, so L1 by L2 is equal to what? 2. L1 by L2, the ratio of the initial length divided by final length will be 2. Clear? Now the volume is constant. So in both the cases the volume of the rod will be constant. So what is the volume of the rod before? Pi R1 square into L1, that is the volume. Clear? This is the area into length, that is the volume. Here area, new area into length. Clear? New area is pi into R2 square into L2. Pi will be cancelled. So R1 square by R2 square is equal to L2 by R1. So it is reversed. R2 square by R1 square is equal to what? L1 by L2 is equal to what is the value of L1 by L2? 2. So I am writing here L1 by L2 is equal to 2. It is number 1 equation. So up to this, hope you have understood. Clear? So I am once again I am explaining. So in a cylindrical rod is there. Clear? So the length of it is made half. Clear? The length of this is made half. Now the initial resistance was R1. We have to find out the final resistance. How much? R1 is equal to R. We have to find out, determine the final resistance. Clear? Now see, it is suppose R1 is equal to R is equal to what? Rho into L by A. L means what? I am assuming it is as L1. L1 is the length of the rod. Clear? So what we can write? R is equal to rho into L1 by A. A means what? A means cross sectional area. Suppose the radius of this circle is R1. So what will be happen? What we can write? Pi into R1 square. Clear? So the rod is reformed. That means the length will be half. So L2 is the final length. So L2 will be what? L1 by 2. Clear? So now L1 by L2 is equal to 2. As the volume is constant, so what was the initial volume? Pi R1 square into L1. And what is the final volume? Pi R2 square into L2. So pi will be cancelled. So R1 square by R2 square is equal to L2 by L1. So we are just reciprocal of this. R2 square by R1 square is equal to L1 by L2 is equal to what? 2. Clear? Why? Because L1 by L2 is equal to 2. We already got from here. So it is number 1 equation. So we are finding the ratio of the length of the rod. Clear? Two length, initial length and the final length. Clear? And the ratio of the radius. Okay, 2 radius, final radius square divided by initial radius square is equal to what? 2. Now, what resistance of the rod? R2. Okay, after reformation, R2 is equal to rho into what? L2 by A2. L2 means final length. L2 means what? This is L2. L2 means what? Final length. Okay, divided by what? Initial final cross sectional area. So L2 into just like same. A2 means what? Pi R2 square. Clear? So now what we can write here? R1 by 2. What is R1? R1 we can write this one R1 by R2. R1 means what? R1 means rho into L1 by pi R1 square. Rho into L1 by pi R1 square. And R2 means what? Rho into L2 by pi R2 square. Rho into L2 by pi R2 square. Clear? So pi will be cancelled. So it will be what? L1 by L2 into R2 by R1 whole square. Now R2 square by R1 square means what? 2. Or we can write L1 by L2 instead of R2 by R1, R2 square by R1 square, we can write what? L1 by L2. So here L1 by L2 is there, and instead of R2 square by R1 square, we can write L1 by L2. So L1 by L2 into L1 by L2 is equal to what? What is the value of L1 by L2? 2. So 2 into 2, that means 4. Clear? Now R1 is equal to what? 4. Just call multiplication. R1 is equal to 4 R2. So R2 is equal to what? R1 by 4. So R1 means nothing but R, the resistance which is given R by 4. So option B will be correct. Okay. So R1 is equal to R2 is equal to the final resistance of the cylindrical conductor. Okay. If the length of it will be half, then it will be R2 is equal to R by 4. 1/4 of the initial resistance. So students, we will solve all the types of the numeric problems as well as the theoretical problems, which basically used to come in the NEET or joint exams. Clear? In case of the physics. So I hope this you have understood. Clear? So you have to practice this at home also. Copy the sum, pause the video, see how I have done here, then practice without watching. Clear? So if you are facing any problem, then write to me in comments. Clear? So hope you have understood this. Now let us move to the sum number 2. Clear? Okay students, now let us move to sum number 2 or numeric problem 2. So a wire of resistance 4 ohm is used to wind a coil. Suppose a wire is there. Clear? So the resistance of the total resistance of the wire is what? 4 ohms. Clear? The total resistance of the wire or conductor is 4 ohms. Wind coil of radius 7 centimeters. So we are wounding a coil. Clear? We are wounding a coil. Clear? Okay. Having a number of turns in it with this wire. We are wounding a coil. Okay. So the radius of the coil is what? 7 centimeter. The radius of the coil. Okay. With this wire we are preparing. Suppose the length of the wire is suppose L. Clear? So it is what? The radius of the coil is 7 centimeter. Clear? Now diameter, the wire has a diameter of 1.4 mm. And the specific resistance means resistivity. So resistivity rho is given. Rho is equal to what? 2 into 10 to the power minus 7. Clear? Specific resistivity of the material is this. Clear? The number of turns of the coil is what? 40, 50, 60, 70, whatever. We have to first solve the sum. Clear? Now we have to find out the value of n. N means the number of turns. Let the number of turns be n. Clear? So the total length of the wire means what? The perimeter of the circle into the number of turns, because with this wire only we have formed a circular coil as well as the number of turns is n. So the perimeter of each circular coil into the number of turns, that will be what? The total length of the wire. Clear? So what is the perimeter? 2 pi r, perimeter of a circle, clear? 2 pi r into the number of turns, that is nothing but equal to the total length of the wire. Okay, now it is what? 2 pi into what is the r is given, clear? The radius 7 centimeter is given, so we are transforming it into meter, clear? So 7 into 10 to the power minus 2, clear, into n. So that is what? That is nothing but the total length of the L is equal to total length. Okay, total length of the wire. Okay, now the resistance R is equal to what we know? Rho into L by A. Okay, so the resistance is given 4. The resistance is given 4. So we are writing, instead of R we are writing 4. Clear? Is equal to what? Rho. Value of rho is given here. 2 into 10 minus 7. 2 into 10 minus 7 into what? L. What is the value of L? The total, these things is the value of L. Okay, this is equal to L, or L is equal to this. So what we are writing? 2 pi into 10 to the power 7 10 minus 2, clear, into n. Okay, divide by A. A means what? The cross sectional area. So what is the area of a circle? Area of a circle is pi r square. Clear? Pi r square. So pi into r means radius. Radius is this. Clear? So 0.7 7 to 10 to the minus 2 means what? 0.7 to 10 to the minus 3 r square, that is whole square. So pi will be cancelled. So from here we can find out the value of n. Clear? So the value of n after calculation, it will come 70. Okay, so the value of n will come 70. Okay, so the 70 will be, so number of turns will be 72. The option D will be correct. So I am explaining once again. Suppose this is the wire. Okay, suppose this is the wire. A wire is given. Suppose this is the wire. Clear? The total length of the wire is L. Clear? So the wire is what? Wound. Okay, the wire is wound. Clear? The wire is wound. Okay, to prepare a circular coil. Okay, so let the number of turns is n. We have to find out the value of n. Okay, so let the radius of the circle is r. Okay, so now what happened actually? Let the number of turns be n. So the length, total length of the wire is what? The radius, the perimeter of the circle into the number of turns of that circle. So perimeter 2 pi r into n. So 2 pi into the value of r is given 7 to 10 to the minus 2. Okay, into n. Clear? So resistance r is equal to rho into L by A. So the value of L is this, and rho is given. Clear? Rho is given, and value of A means what? The area of the circle. Clear? The area of circle is pi r square. So that we are writing here. So from this equation you can easily find out the value of n, which is coming 70 after calculation. Clear? So the number D will be the correct option. Okay, why I have done the calculation before? So that the time can be saved. As many as number of sums we can solve, that is better. Okay, because different type of sums may come, okay, in the examination. So the practice required. Okay, the practice required, as much as we will practice. Okay, the numeric problem, physics, the main part is theory as well as the numeric problems. So if you can do the numeric problems well in physics, you can be very much sure that you can crack the NEET or JEE main or advanced. Clear? Because physics is the common subject. In both the cases you have to appear the physics for the examination. Clear? So I hope this sum you have understood. So now let us move to the next sum. So students, now here it is another MCQ questions, question number 3 for today's episode. The electrical resistance of a conductor depends upon. Clear? So resistance of the conductor depends upon the size of the conductor. Yes, it will depend upon the size. Suppose a pipe is there and the water is flowing inside the pipe. So if the size of the pipe is what? Big, then what? More amount of water can flow. That means the resistance will be less. Clear? So that means what? In case of the conductor is also same. So it will depend upon the size of the conductor. Clear? You can assume the flow of current as the flow of water inside a water pipe. Okay. So the size of the conductor, if it is big, that means what? More resistance will be there. If it is small, then less resistance will be there. Okay. Now number B, temperature of the conductor, obviously. Clear? If the temperature increases, then resistance of the conductor will also change. Clear? It will increase. If decreases, then it will decrease. Okay. Geometry, that means shape of the conductor. Okay, obviously depending upon the shape, the number of free electrons depends, clear. So it will also depends upon the shape of the conductors or geometry of the conductor. And number D, all of these. So all of these, the number D, these options will be correct, clear. So all the parameters, size of the conductor, temperature of the conductor, geometry of the conductor, the resistance of the conductor depends, clear. So that's why the option D will be correct, all of these, clear. So it's a theoretical question. Okay, 4 options are given, very simple one. So option D will be correct, clear. Now let us move to the next problem, problem number 4. So students, now here let us move to the problem number 4. Okay, so a wire of 15 ohm resistance is stretched by 1/10 of its original length, and the volume is kept constant, just like the first sum we have done. Volume is kept constant, the resistance will be, what will be the resistance? The first sum, if you can remember, we have done the cylindrical shape conductor. Okay, the length will be half. Then before we have to find out the change of resistance in the new cylindrical shape conductor, which length is half. The volume of both the cases are constant, but here the wire is stretched. Okay, so the wire is suppose the initial length and it is stretched. Okay, it is stretched, clear. And what, the volume is kept constant and is stretched by 1/10 of the original length. Okay, so it is stretched by 1/10. So increase is 1/10 of the original length. That is the increase in length. So total increase is what? The original length plus the increase in length. That will be the ultimate length of this new wire. Okay, so what we have to find out? We have to find out the resistance. Okay, it will be 15.18, 81.15, 51.18, 18.15. Okay, what will be the answer? So now let us start here. As the length of the stretched conductor is increased by what? 1/10, 1/10 of the original length. Okay, so the resistance is increased by 1/10 of the original length. So suppose this is the original length and suppose it is 1/10. Okay, so the length is increased by 1/10, clear, of the original length. So what will be the total length of this? Original length plus what? 1/10 of the original length, clear. So now what will happen? The new length L2 is equal to what? L, suppose L is the original length plus what? L by 10. So L by 10 is what? The 1/10 of the original length, that is increased. So original length plus the 1/10 of the original length is L by 10. So if we do the 10 LCM, so 11L by 10. The volume is constant. So in both the cases, what is the volume? Cross section area pi R1 square into L is equal to the new radius of the wire is suppose R. Okay, suppose this is the wire. This is the wire. The new radius is R2. Clear. So pi, the cross section area will be what? Pi R2 square into L2. Clear. So pi will be cancelled. Pi will be cancelled. So R1 square into L is equal to R2 square into what? L2 means what? L2 means what? We can write this 11L by 10. 11L by 10. So R2 square is equal to 10 by 11 into R1 square. Okay. So R1 square into L is equal to R2 square into 11L by 10. So R2 square is equal to what? 10 by 11 into R1 square. Okay. So this is, you can give equation number 1. So here we have found the R2 square is equal to a relationship between the new radius to the original radius of the wire. Okay. Now, so suppose this is the resistance. Okay, this is the radius and this is the resistance, capital R2. What we know? Rho into L by A. What is the formula we know? R2 is equal to rho into L by A. Okay, so rho as it is we have written over here. So what is the value of L? L means the value of L is what? 11L by 10. Okay, the new length. Okay, so 11L, 11 into L by 10 or 11 by 10 into L. Okay, and the cross section area, M is cross section area, it is what? Pi R2 square. Clear. So now what it is? Just we are writing 11 by 10 into rho into L. Okay, and in the here pi into what is the value of R2 from here? From here what is the value of R2? 10 by 11. Okay, into R1 square. Clear. This is the value of R2 we are writing from here. The value of R2 we are putting over here. Okay, so it will be what? It will be the reciprocal, that means what? 11 by 10 to 11 by 10, that means 11 by 10 whole square into what is there? Rho into L, rho into L, and what is there as the denominator? Pi into R1 square, pi into R1 square. Clear? So 11 by 10 whole square into rho into L by pi R1 square. Now the initial resistance R is equal to what we know, rho into L by pi R1 square. This is the cross sectional area, initial cross sectional area. So rho into L into pi divided by pi R1 square is equal to what is given, the initial resistance what is given, 15 ohms. Clear? So 15 ohms we can write. So see, this is nothing but the initial resistance R1. This is nothing but the initial resistance R1. So so we can put the value 15, okay, instead of this. So we are putting the value 15 instead of this. So 11 by 10 whole square into 15. So after calculating 18.15. So 18.15. So option number D is correct. 18.15 is coming. Clear? So after calculating 18.181, 18.15 is coming. Clear? So this is the sum. Okay, you have to do like this. So this is very common type of sum. Very often it comes in the NEET or joint exams. Okay. So in this way you have to solve this. Clear? So it is it has the similarity of the sum number 1 of today's episode. Clear? But a little bit different. Okay. So you have to practice. So different type of these problems, as much as you will practice, your concept will be clear and you will come to know how to solve this and how to approach this. Clear? So it will be very easy for you if you practice it many times. Clear? So students, hope you have understood this. So now let us to move to the problem number 5. So students, now let us move to the problem number 5. Clear? A space between the concentric spheres of radius. So two concentric spheres are there. Okay. One is the inner sphere. Two concentric spheres are there. 1, 2. Clear? It is the inner sphere, its radius is R1. It is the outer sphere, its radius is R2. Clear? Now, so two circles are there. Okay, and R1 is less than R2. Obviously, it is the inner circle, so the radius of the inner circle will be less than the radius of the outer circle. And two concentric circles, that means the center for both the circle is common. Okay, or same. Now, it's filled with the material of resistivity rho. So it is in between the space, it is filled with the materials whose resistivity is rho. Clear? The resistivity of the materials is rho. Now, find out we have to find out the resistance between the inner and outer surface of the materials. Inner and outer surface, the resistance of these materials. Inner and outer surface of the materials we have to find out. Clear? The four options are given. The option number 1, R1 by R2 into rho by 2. Option number B, R2 minus R1 by R1 R2 into rho by 4 pi. Clear? Option number C, R1 R2 by R2 minus R1 into rho by 4 pi. Clear? And here none of this. Clear? So very easy sum. This type of sums actually very common type of sums for the NEET or joint exams. Okay. So you have to practice this. Now see what we know, R is equal to rho into L by A. So R is equal to rho into L by A. Okay. So now rho into dl by A means what? The cross sectional area pi. Okay. So as it is the what? The sphere. Okay. So the sphere means what? 4 pi r square. Clear? So here we are assuming it as L. So dl means what? The small element. dl means the small element and L means what? The radius. Okay. Any radius of the circle. So what we can write for the sphere? Rho into dl by 4 pi L square. Clear? As the sphere is there, so 4 pi r square is the formula. Okay. Of the area. So now total resistance R is equal to what? Integration. Okay. What is the concentric circles are there or spheres are there? So it is what? R1 to R2. Okay. So the lower limit and this is the upper limit. Clear? Of the integration. Okay. So it is what? Rho by 4 pi is constant. Clear? So dl by L square. So that means what? 1 by L square into dl. So rho by 4 pi into minus 1 by L. So rho by 4 pi. Okay. Into what? This if you put the value. Okay. R2 and R1. Then after calculation what is coming? R2 minus R1 by R1 into R2. So what is the resistance of the internal and between the internal and external surface of the material? Okay, between the two inner concentric spheres. Okay, R1 having radius R1 R2, it will be rho by 4 pi into R2 minus R1 by R1 R2. Clear? So R2 minus R1 by R1 R2. So option B is the correct answer. That will be the correct answer. So once again I am explaining. So suppose this is the two concentric sphere, R1 and R2 are the two internal two resistances. R1 will be less than R2. That means internal sphere is R1 and outer and the external sphere will be R2. Clear? So what do we know? R is equal to rho into L by A. So L means for the small length it will be dl and 4 pi l square. L means what? The radius of the sphere. So it is 4 pi l square. So now the integrating the total resistance, it will be what? L by rho by 4 pi will be considered as constant. So R1 bar 2 is the two resistances, it is lower and it is upper limit, clear. So dl by L square. So L square if we do, it will be minus 1 by L integration. Okay. So this is coming rho by 4 pi into R2 minus R1 divided by R1 R2. So option number B will be correct. So hope you have understood this. So now let us move to the problem number 6. Now it is very easy sum, clear. The problem number 6. So 3 resistors are in parallel, clear. So the parallel, they are connected in parallel 2 ohm, 4 ohm and 5 ohm. Okay. So now with a battery, the negligible internal resistances, clear, and the EMF of the battery is 20 volt. So very easy. So the current will come here and it will branch into 3 segments, I1, I2 and I3, clear. So I1 from Ohm's law, what we know? V is equal to I into R, clear. So I is equal to what? V by R, clear. So this is the formula. So now I1 is equal to what? V means what? The voltage or EMF of the battery. Okay. So V by R1. R1 means 2. So and it is what? 20 volt. So as it is the parallel combination, so 20 will be common for all the resistances. Okay. So 20 by 2 is equal to 10 ampere. So I2 will be what? 20 by 4. 20 by 4 is equal to 5 ampere. I3 will be what? 20 by 5 is equal to 4 ampere. Okay. And 20 by 4 is equal to 5 ampere. So I is equal to what? The sum of I will be what? Suppose this is I. So I will be divided in 3 part, I1, I2, I3. Again it will meet over here and it will form I. So I is equal to what? I1 plus I2 plus I3. So that means 10 plus 4 plus 5, that means what? 19 ampere. Okay. So option number 3rd will be correct. Okay. So it will be 19 ampere. So here what happened actually? Okay. The battery is there and 3 resistors are there which are connected in parallel. So the common 2 terminals are same. Okay. So the main current I is dividing into 3 parts, I1, I2, I3. So it is I1 will pass through 2 ohm, I2 will pass through 4 and I3 will pass through 5, clear. So I1 is equal to what? V by R1. So V means what? 20 by 2 is equal to 10, I2 is equal to V by R2 means 20 by 4 is equal to 5 and I3 is equal to V by R3, that means 20 by 5 is equal to 4. So I means the summation of the 3, okay, sum of 3 I1, I2 and I3. So I is equal to I1 plus I2 plus I3 is equal to 19 ampere. So option number C will be correct. So students, hope you have understood this. Now let us move to the problem number 7. Students, now here problem number 7, the voltage and current VI graph. From the Ohm's law, you know the VI graph, okay, voltage and current. The VI graph for a conductor at 2 different temperatures, one is T1 and another is T2, clear. So the VI graph for a same conductor at 2 different temperatures is given, okay. So we have to find out the relationship between T1 and T2. The options T1 greater than T2, T1 less than T2, equal to T2, T1 is equal to 1 by T2, clear. So the VI graphs actually what it gives, the slope of the graph gives the resistance of the conductor at different temperature, okay. So as the slopes increases, the resistance will also increase. So see here, this is what T1 and this is what T2. So here the slope increases, so the resistance will increase, here the resistance will decrease, clear. So now the thing is that the resistance will increase only at the higher temperature, and if the temperature decreases then resistance of the conductor will also decrease, clear. That means what? It is the conductor having the temperature, when the conductor is at a temperature T1, it has higher resistance than the temperature at T2, okay. So that means what? We can say that T1 will be greater than T2. Okay, the resistance of the, if the temperature is high, then it will, the conductor generally will have more resistance, and if it is low, then the resistance will also decrease. So that means what? That means that T1, obviously because at T1 the slope is higher than this, okay. So that in that case we can say that the T1 will be, must be greater than T2, clear. So T1 will be greater than T2, okay. So option A will be the correct answer, okay. So this will be the answer of this problem number 7. So hope students you have understood this. Now let us move to the problem number 8. So students, now let us move to the problem number 8. Okay, a charge particle having deed velocity of this deed velocity is given, and as it is a velocity, so the unit is meter per second. Clear? In electric field, okay, the electric field is given what 3 × 10⁻⁻10, okay, volt per meter. Okay, mobility is, we have to find out the mobility. The 4 options are given. Option number A 6.5 × 10⁶ meter square per volt per second. Option number B 2.5 × 10⁶ meter square per volt per second. Option number C 2.5 × 10⁴ meter square per volt per second, and D 6.5 × 10⁴ meter square per volt per second. So only the simple using formula. Clear? So the mobility of a charge particle mu, remember the formula, mu is equal to what? Mod of, okay, Vd by E. What is Vd? Vd means the deed velocity of any particle, charge particle. Clear? So Vd by E, E means the electric field. Okay. So both the values of the deed velocity as well as the charge particle have deed velocity. The deed velocity as well as the electric field is given. So the mobility of charge mu is equal to mod of Vd by E. Vd means deed velocity and E means electric field. Okay. So what is the value of deed velocity? 10.5 × 10⁻⁴ divided by E means what? 3 × 10⁻⁻10. Clear? So after this it is what? So it will be 2.5, okay, 10⁻⁶ and -4, or 10⁻10 and -4, then 10⁻6. So when it will go up, then it will be 10⁻+6. So 2.5 × 10⁶ meter square per volt per second. So 2.5 × 10⁶, 2.5 × 10⁶. So option number B will be the correct option. Okay, option number B. Clear? So here only the mobility of charge particle, which formula have to use? Mobility of charge particle mu is equal to mod of Vd by E. Okay, Vd means nothing but the deed velocity of the charge particle divided by E means what? The electric field, value of the electric field. So both the values are given in the questions. So we are putting the values and calculating. So this is coming. So option number B will be correct. Okay. So students, hope you have understood this problem. Now let us move to problem number 9. So students, now let us move to the problem number 9. So this type of conceptual questions also may come in the examination. For which of the following dependencies of deed velocity Vd and electric field E is Ohm's law obeyed? That means it will obey the Ohm's law. Clear? So 4 conditions are given. That is what? Deed velocity is proportional to the electric field. Deed velocity is proportional to the electric field square. Deed velocity is proportional to the square root of the electric field, and deed velocity is proportional to the 1 by electric field. Clear? That means reciprocal of the electric field. Now deed velocity Vd is equal to what? I by N E, N A into E. Okay. N means what? Number of electrons. Okay. A means what? Cross sectional area, and E means what? E means the charge of each electrons. Clear? Now it is what? J by Ne. Okay. So J by Ne. So we are putting the value of J over here. So it is what? It will be sigma into capital E. Clear? So sigma into capital E. So I am writing here in bracket. Why? Because this part is constant. Clear? The number of electrons is constant, the charge of the electron is constant, the sigma is constant, and T. So what we can write, if we want to omit this equal sign, okay, by omitting the constant part, then we can write Vd is proportional to E. Okay, so which option will be correct here? Vd proportional to E. Vd means deed velocity will be proportional to the electric field. So for this condition, the Ohm's law will be verified. If for the deed velocity of a charge particle is Vd and E is the electric field. Okay, so it will obey the Ohm's law for this condition. Vd out of these 4, this option A will be correct. Vd will be proportional to E. Okay, so this option will be correct for this question. So students, hope you have understood this. Clear? Now let us move to the sum number or the problem number 10. Okay students, now it's the conceptual theoretical questions. Match the column. Column A, okay, column 1, column 2 or AB, whatever is given. Okay, so here what? Ohm's law is applicable to, Ohm's law is not applicable to, and alloys have. Okay, alloy means the mixture of metals and other materials. Okay, so what we know in the theoretical portions, Ohm's law is applicable for the metals. Okay, that means what? VI graph. Okay, it will obey the Ohm's law. Clear? And it's not applicable. Okay, for the semiconductor devices. Okay, diode, triode. Okay, these are the semiconductor devices. Okay, for the semiconductors it is not applicable. Clear? And alloys have what? High resistivity. Okay, or high resistance. Okay, so very easy. So Ohm's law is applicable to metals. That means A is matching with P. Clear? A is matching with P. Ohm's law is not applicable to what? Semiconductor, diode, triode, electrolytes. Okay, it is not applicable to. Clear? That means what? B is matching with R. Okay, and so rest what? Alloys have greater resistivity. Okay, so that means C is matching with Q. Clear? C is matching with Q. Now AP, clear? AP, BR and CQ. That means option number B will be correct. Clear? So option number B will be correct. So Ohm's law is applicable for the metals. Ohm's law is not applicable for the semiconductor devices. That means diode, triode. Okay, or electrolytes. Okay, and alloys have higher resistivity. Okay, so this is very easy. So AP, BR, CQ. AP, BR, CQ. So option number B will be correct. Clear? So students, hope you have understood this. Now let us move to the problem number 11. Okay students, so now it is problem number 11. Which of the following graphs represent the Ohmic conductor? Very easy. Clear? So 4 graphs are given. 4 graphs are given. What we know from Ohm's law? V is equal to what? I into R. So that we know from the Ohm's law. Clear? So it is nothing but the equation of the straight line. Clear? And the slope of this straight line, okay, represents the resistance of the conductor at that particular temperature. Okay. So now what is it? Is not a straight line, it is not a straight line, it is not a straight line. So this is the straight line. So option A will be correct. Okay. So for the ohmic conductor, it will obey the Ohm's law. What is the Ohm's law? V is equal to I into R. So it will represent the equation of a straight line. Clear? So and the slope of that particular straight line will represent the resistance of the conductor at that particular temperature. So here this is the straight line. Okay, it is passing through it. It is a straight line. It is not a straight line. It is not a straight line. It is not also not a straight line. So straight line. So that means what? So this will be the correct option. It is the equation of a straight line. Okay, the slope of it will represent the resistance of the conductor. Clear? So option A will be correct. Now student, so hope you have understood this. So now let us move to the problem number 12. Okay students, so the next problem is what? The VI characteristics is given. Okay, so it will represent what? Ohmic conductor, non-ohmic conductor, insulator and superconductor. Clear? So out of 4, which option will be correct with respect to this figure? Clear? So ohmic conductor will be a straight line, it is not a straight line. So that option is not correct. Now non-ohmic conductors, especially the what are the non-ohmic conductors will not obey the Ohm's law, and basically the semiconductor, that means what? The diode, triode, these are okay the non-ohmic conductors. And in case of the triode, when I will discuss about the modern physics, I will say the forward bias and reverse bias. Okay, how the triode valve is connected. Okay, so here so it is what? Not a straight line, and it is a non-ohmic conductors. This portion is for the reverse bias and this portion is for the forward bias, okay, of the semiconductor triode valve. Clear? So it will be what? Non-ohmic conductors. So option number B will be correct. So it will be non-ohmic conductors. So this graph will be for non-ohmic conductors. Clear? Or semiconductor devices. Clear? So IV characteristic shown. If this type of figure is given, then you have to write here non-ohmic conductors. So hope you have understood this. Clear? So now let us move to the problem number 13. Okay students, so now it is the problem number 13. So the two metallic wires of identical dimensions are connected in series. Clear? In series means that they are connected in series means like this. Clear? So suppose the resistance is R1 and R2. Okay. Now this is sigma 1 and sigma 2 are the conductivity. Okay, conductivity of the metals respectively. The effective conductivity of the combination will be effective conductivity of the combination. Clear? So now what we know? R is equal to rho into L by A. Okay, so the conductivity is what? Reciprocal of the resistivity. So what we know actually? Actually we know R is equal to rho into L by A. So rho means the reciprocal of the conductivity. Okay, so what is that? 1 by the conductivity is what? Sigma into L by A. That we can write. instead of rho, in terms of conductivity we can write like this. Clear? So I have written like this: R is equal to 1 by rho 1 by sigma into L by A. Clear? Now as these are connected in series, so equivalent resistance will be what? R is equal to R1 plus R2, that will be the equivalent resistance. So instead of this, what? This is the formula. Here R2 resistances are there, that's why what? 2L by what? It is the effective conductivity sigma S into A. Okay, A means cross sectional area is equal to what? For this R1 sigma L divided by what? Sigma 1 into A plus R2 means L divided by sigma 2 into A. Okay, okay. Here we are writing what? R is equal to 2L by sigma S into A plus L is equal to sigma 1 or delta 1 into A plus L by delta 2 into A, okay, or sigma 2 by A, whatever you are taking. Clear? So here we are 2 by this, okay. So L by A will be cancelled for all the sides. So 2 by this is equal to 1 plus sigma 1 plus 1 by sigma 2. Clear? Or delta 1 plus delta 2. Okay, so delta 1 delta 2 will be the LCM. So delta 1 plus delta 2. Clear? So delta is equal to what? 2 delta 1 delta 2 by delta 1 plus delta 2. Clear? So this is which option? Delta 1 delta 2 by delta 1 plus delta 2. Clear? Option number D. Option number D will be correct. Clear? So students, hope you have understood this. So I am explaining once again for your benefit. Clear? So or for your understanding, better understanding. So what R is equal to rho into L by A. Reciprocal of the resistivity is conductivity. So that means 1 by sigma into L by A. Clear? So now R is equal to, these are connected in series. So R is equal to R1 plus R2. Clear? So R we are writing this and R1 plus R2 we are writing this. Clear? Then after calculation this is coming. So option number D will be correct. So hope you have understood this. Okay. Problem number 13. Now let us start problem number 14. Okay students. So now let us move to problem number 14. Which of the following is correct for VI graph for a good conductor? Clear? So we know that the conductor or the metal which will obey the Ohm law will be a straight line. That means here this and this are almost straight line, a little bit deviation is there. But we know that, okay, for a good conductor it will not obey exactly the Ohm's law. A slight deviation of the straight lines can be seen. Clear? It will not obey the exactly, this is for the metals which will exactly obey the Ohm's law. Clear? Number C. But it is given which is correct for a good conductor. So for a good conductor it will not exactly obey the Ohm's law. A little variation or deviations will be there in the straight line. Clear? In the straight line. Okay. So here see a little bit deviation is there in the straight line. Clear? So for this will be the good conductor. This graph will be for the good conductor. It will not obey exactly the Ohm's law. A little bit deviation we can see. Clear? In this graph almost a straight line but little bit deviation we can see. So option A will be correct for these questions. So hope you have understood this. Okay. Now let us move to the problem number 15. So students, here the last problems of today's episode, last but not the least. Okay. So problem number 15. Arrange the following materials in increasing order of their resistivity. That means increasing order. That means the lowest value we have to write first and the highest we have to write last. Okay. So the resistivity, okay, the lowest value, that means it will be as much as the value of resistivity will low, it will be a good conductor. Clear? So here copper is a very good conductor among these. Clear? So the resistivity will be low. So what is the resistivity of copper? 1.7 into 10 to the minus 8. Then comes nichrome. It's an alloy. It will be 100 into 10 to the minus 8. Clear? Then it's germanium 0.46. Then silicon 2300. Its resistivity is much higher. Okay. So copper is the lowest. Then nichrome. Then germanium. Then silicon. So how we can write? Copper. Then less than what? Nichrome. Then less than what? Germanium. Then less than what? Silicon. Okay, silicon. Clear? So which option is correct? Copper. Yeah, copper is first here. Copper, nichrome, germanium, silicon. So the option A is correct. Clear? So the resistivity of copper is lowest. Then nichrome greater than copper, then germanium greater than nichrome and copper, then silicon greater than these three. Clear? So this will be the, as the resistivity increases, then that means what? It will not be a good conductor. Clear? It will oppose more electric current to flow through it. As the resistivity decreases, it will be a good conductor. Current electricity will not get much obstructions to flow through it. Clear? So these options A will be correct. So hope students you have understood today's episode. So this type of MCQ, okay, on numerical based as well as the conceptual theory based we will solve. So from this chapter I will try to solve more than 100 MCQs, okay, from the current electricity chapter, and then we will move to the next chapter also. So all will be uploaded in my channel Page Scholar. So if you still not subscribe my channel, subscribe it now, and keep continue watching the channel, and also write in comments that if you are not understanding any topic properly or what type of content you want to see. Clear? You write it in the comment. So I will eagerly wait for your comments also. Okay. So thank you students.